let's solve the problem about the movie 2001. We want to estimate the radius of that wheel-shaped space station, and what are the data that we have? Well, on the one hand, we see people walking as if they were on Earth, so we are going to assume that the centripetal acceleration inside is the same as gravity, so we will say that a centripetal is 9.8 meters per second square. So, and we can measure the time that it takes to rotate a quarter of a circumference. And if you look at the time that one of those bars is moving just by a quarter, you see that that's about 13 seconds. So the total period of going, so you have this space station, you can look at, just mark one position, wait until just the next bar goes to the same position and count that time. And from what I counted, t is equal to 4 times that time of a quarter of a rotation, and that is 54.8 seconds. So that's the period of the rotation, about 1 minute. How can we know the radius? Well, you know from centripetal motion, from rotational motion and centripetal acceleration, that the centripetal acceleration of the people right at the walls of that ring. So people are walking here and walking here and walking here, and that's just because centripetal acceleration. We know that from Newton's second law, and that is just the particular case that we are interested in now. And what is the velocity? Well, the velocity is just 2 pi r divided by the period. We have estimated the period about 55 seconds. We want to calculate the radius, but this velocity we will plug it into here, and this force we are assuming that this is g. So with all of this we get that mg we get this expression here. Now look that we cancel the masses and we have g, which we know, r, and r, which we want to calculate, and t that we have measured. If you solve this for r, then you get if you use the calculator, you will get that the radius is of 750 meters, which looks like a very big number, but if you look at the scenes, at the beginning you saw that huge entrance to the ship, which is right at the center, and then when they show us the whole space station, you see that that huge entrance is relatively small in comparison with the whole wheel. So it makes sense that it is about 700 meters. It could, if it was slightly smaller, then gravity would be slightly smaller, but it wouldn't be uncomfortable to walk on a gravity of about 8 instead of about 10 meters per second square, which would be also pretty reasonable. Now let's talk about friction. Now you're going to watch a scene from the movie Hancock, and I want you to think about the physics of that scene. In particular, I want you to calculate or estimate the time that Hancock would need to stop the train and the distance that he is going to make because of stopping the train and because the train is pushing.